Hi everybody. Today we are going to talk about volumes of solids. So let's talk about this. Let's look at our picture. Here I have this shape and it's made up of these little cubes. Okay, each one of these, let's say the dimensions are 1 inch by 1 inch by 1 inch. So this is 1 cubic inch. Here's another cubic inch. So this entire shape is made up of 4 times 3, 12 of these cubic inches. The volume then is 12 inches cubed. Now what's the volume? Well, I've got 12 in the top row, I've got 12 in the bottom row, giving me a total of 24 cubic inches. So I took the amount that I had on this top part and then multiplied by how many stacks of this I have. This would now have a volume of 36 cubic inches. And now I have a volume of 48 cubic inches. So the idea of volume is you take the area of the base and multiply by how many times it's stacked on top of itself, what the height is of the prism. So our volume is the area of the base times the height. Remember, capital B means the area of the base. And the height is the height of the prism. So I have this rectangular prism drawn. So go ahead and draw that in your notes. And I want to find the volume of this. Well, rectangular prisms are the easiest ones to deal with because it's easy to find the area of the base. So the volume is the area of the base times the height. Well, let's make this bright pink one up here the base. Well, the dimensions are 9 by 10, so the area of the base is 90. The height of the prism is 3. Giving me a volume of 270. And what would my units be? Yeah, the units would be inches cubed because we're saying how many of those little cube inches would fit. We're multiplying inches by inches by inches, giving us inches cubed. You might know the volume formula for this rectangular prism to be length times width times height, and that's another way to find the volume. That works when the base is a rectangle, but we're going to branch out and have other types of bases, so that's why I gave you this more general form. Let's try another problem with volume. This time I have a hexagonal prism. So start by drawing a hexagon. Then you could draw 3 sides of a hexagon behind it and then connect those up. Now, I did not indicate what all the sides are. I do intend this to be a regular hexagon as the base. So all those angles are equal and all the sides are 8. And we're going to use this volume formula, the area of the base times the height. Well, the area of the base is the hard part, just like it was with finding surface area, because the base is going to be different depending on what kind of polygon we're talking about. So I know it's a hexagon, it's a regular hexagon. I'm going to use 1/2 times the apothem times the perimeter. So let's draw our triangle in our hexagon. Well, that splits the 8 up. We've got 4 and 4, giving us an apothem equal to, 4 radical 3. And we don't really need it, but this hypotenuse of the right triangle would be 8. Yes, the 30, 60, 90 triangle. So the area of my base is 1/2 times that apothem, 4 radical 3, times the perimeter of the base, the perimeter of the hexagon, which would be 8 times 6, 48. Let's see, a half of 4 is 2, times 48 is 96 radical 3. My volume then, 96 radical 3 times the height. Remember, it's the height of the prism, so it's from congruent base to other congruent base, which is this length of 12. When I multiply those, I get 1,152 radical 3. And if there was a unit, which there's not in this case, I would have units squared. So meters squared or feet squared or inches squared, whatever the case might be. Let's try another problem with volume. This time I have a right triangular prism. So let me give you a minute to draw that. I know to find the volume, I'm going to use this formula, area of the base times the height. Well, the base is a triangle, and it's a right triangle. And right triangles are the easiest type of triangles to work with because our base and our height are these two sides that are perpendicular to each other. We're just missing that side. How can we find that side? Yeah, we can't use special triangles because we don't know that it's a 30, 60, 90 or 45, 45, 90. So we are going to use Pythagorean theorem. And this is one of those nice, neat triples. You end up getting 6. That means the area of the base, the two sides that are perpendicular, we're going to use as our base and our height. So 1/2 times the base of 8 times the height of 6, giving us 24 as the area of the base. Volume is 24 times 18 then. Remember, the height is not the height of the triangle. It's the height of the prism. And I got 432 for my answer. Once again, if we were talking units, we're talking volume, we're talking 3 dimensions. How many little cubes fit in this? So it would be units cubed. Okay, let's try another prism with a triangular base, but it's just a different type of triangle. This time, instead of the right triangle, we have an equilateral triangle. We could have an isosceles triangle. The possibilities are pretty much endless here. Okay, I want to find the area of this rectangular, no, I'm sorry, this triangular prism. I want to find the area of the base. So I have two options. I could do 1/2 base times height, or I could do 1/2 AP because it is a equilateral triangle. I think 1/2 base times height is going to be our easier bet here. So let's go for that. So draw in your height. That splits the 10 in half. Now, this was an equilateral triangle, which means all the angles are equal, which means they must all be equal to what? Yeah, to 60. Splitting this 60 in half gives us our good old 30, 60, 90, which means our height is 5 radical 3. So the area of the base, 1/2 base times height. The base is that entire base, 10. And the height is 5 radical 3. So the area of the triangle is 25 radical 3. The volume then would be that area times the height. Now this is where people sometimes get confused. This is now the height of the prism, where this h was the height of the triangle. And I know we're using the same letter to represent them. You just have to keep straight what you're working with here. So I'm talking about the volume. I'm talking about the height of the entire prism, not the height 5 radical 3 of the triangle. So I'm going to multiply those, and I get 350 radical 3. Once again, if there was a unit, it would be, of course, units cubed. Okay, let's try one more of these volume problems. We're actually going to do the cylinder problem. To draw the cylinder, if you have a geometer handy, I would use one of the ovals and then draw half the oval below it and then connect them up, and you've got your cylinder. Well, just like with lateral area and surface area, we could use the same formulas as we did for cylinders as we did for prisms. Same idea with volume. I still can do the area of the base times the height formula. It's just that my base is a circle, and so I have to use my area of a circle formula. The diameter of this base is 6, which means the radius is 3. That gives me an area, pi r squared, of 9 pi. And then we multiply by the height, 8. We are given a unit this time, so I want to make sure I include that in the answer. This is 72 pi inches cubed.